Welcome to lesson 2. In this lesson, we'll tackle the issue of problem recognition. That means, as a computer programmer, if somebody asks you to write a program to solve a problem, how do you recognize what your program has to do? In this lesson, we'll look at how we define a problem and how we decide if the problem is solvable. We'll learn what an algorithm is and how it helps us to solve a problem, and we'll briefly review the set of problems that are impossible to solve. So problem recognition basically means that we have to clarify what the inputs and the outputs to our process should be. And finally, we have to decide, is there a path that will take us from the inputs to the outputs? If any of those factors are missing, it's going to be hard for us to write a computer program. If the problem is solvable by computational methods, there must be 4 features to the problem. One is that it must have clear inputs, and typically those inputs should be quantifiable. That is, they should be expressible as clear quantities. There must be well-defined outputs. It must be clear what outputs the user wants to see. There must be steps that will get us from the inputs to the outputs. If there's no way of getting from the inputs to the outputs, then we can't write a program. And finally, those steps must ultimately be logical or mathematical, because that's the kind of processing that a computer can do. If we've managed to get that information, then we typically plan a program using what we call the IPO model. The IPO model sets out the inputs that are going to go into our program and the outputs that we have to produce, and the processing, that is the steps that will turn the inputs into the outputs. Those steps in between the inputs and the outputs are called an algorithm. So an algorithm, it's a term that's not only used in computer science, it means any set of steps to solve a problem. But in computer science, it's specifically the steps of our program. An algorithm needs to be complete. That is, if you run the algorithm, it will contain everything that you need to do to turn the inputs into the outputs. And it needs to be repeatable. That is, it's not just a one-off lucky chance that you've got the outputs, but that reliably, every time you run the algorithm, it will get you the results you need. Algorithms are usually built using 3 basic program structures. A sequence of steps in order that will get you to your goal. A selection structure where there are multiple different ways that the program could go, and based on a logical test, it will go one way or another. This is a structure using if or elif. And finally, iteration, or an iterative structure, that's a loop. So if you've done programming before, you'll know about loops. So in conclusion, if you're asked what are the basic structures of a computer program, the basic foundational structures are sequence, selection, and iteration. As well as having steps that will take us from the inputs to the outputs, we've got to consider how many steps there are. The only way that we can solve a problem is if the steps are finite in number. If solving a problem takes an infinite number of steps, we can't write a program to do it without truncating the steps. An example would be to write down all the prime numbers that exist, because there are an infinite number of prime numbers. So a program that would output those would run literally forever. There is a third category of program which we count as impossible, and that is where the number of steps is what we call intractable. That means there are so many that realistically we couldn't run them. Once we've decided that a problem is solvable by computational methods, there are a lot of different methods that we can use. And I'm not going to go through those now, but that's a sneak preview of some of the computational methods that we'll be looking at in the weeks ahead. Abstraction I've highlighted because we've actually already done that one. So let's briefly recap what we've learned this lesson. Remember, you should have revision notes so that you can come back to this and learn it. You should know how to recognize and define a problem. You should understand what the IPO model is. You should know the 3 basic program structures, and you should know how to recognize whether or not a problem is solvable by computational methods. So I'm going to leave you with a programming task. This is to create a program which will generate the cost of hiring a car. I've given you 2 facts about the cost based on the number of days that you've hired the car for and how many miles you've driven the car for. Based just on that information, work out what the inputs and outputs of the program are, the steps that will get you from the inputs to the outputs, and write a program that will solve the problem. Okay, I'll look forward to seeing those and see you in the next lesson. Bye for now.